Theorem 1.1 Existence of limit. The limit of a function exists if and only if the one-sided limits are equal. This is how we write it in math notation. The limit of f of x as x approaches a is equal to L if and only if the limit of f of x as x approaches a from the left is also equal to the limit of our function as x approaches a from the right, and it is equal to the same real number L. L is a real number here. So the limit of the function, if it exists, is equal to a real number. I am pointing that out to you because in our previous discussions, we have seen this, infinity and negative infinity. Functions that point towards infinity as x approaches a certain real number. But infinity is not a real number. Negative infinity is also not a real number. And so when you see something like a function that approaches infinity when x approaches a, or a particular real number a, it doesn't mean that the limit for that function exists. For example, this is a rational function defined by 1 over x squared. As x approaches 0 from the left, your function points towards positive infinity. When x approaches 0 from the right, your function also points or approaches positive infinity. So at the first glance, this function as x approaches 0 seems to meet the criteria for the existence of limits. But no, it does not, because infinity is not a real number. So in this case, the limit of 1 over x squared as x approaches 0 does not exist. Another remark. This is a biconditional statement. This is an if and only if statement. So what this means is, if we are told that the limit of our function as x approaches a exists and it is equal to a real number L, then automatically it follows that the one-sided limits also exist and they are also equal to the same real number L. And the second part of this is, if we know that the one-sided limits of our function is equal to the same real number L, then the limit of your function as x approaches a exists and it is equal to L. This is what I will do. I will flash the graphs of two functions. And I will ask you, in which function does the limit exist as x approaches a particular real number? So this one is a piecewise function. Okay, it is equal to 2 when x is greater than or equal to 1. It is equal to 1 when x is less than 1. We shall investigate the limit of this function as x approaches 1. Okay, so this is the other function. Still a piecewise function. This function g is equal to 2, okay, if x is greater than or equal to 1. It is equal to 2 times x. It's equal to 2 times x if x is less than 1. We shall investigate the limit of this function as x approaches 1. This is the question. In which function does the limit exist as x approaches 1? And what is that limit, if it exists? Well, here, okay, look at this. As x approaches 1 from the left, the limit of your function approaches 1. Okay, so this is the value of your function close to when x approaches 1 from the left. But when x approaches 1 from the right, the value of your function approaches 2. So they are not equal. The one-sided limits are not equal. Conclusion, the limit does not exist for this function. How about this one? Look at this. When x approaches 1 from the left, the value of your function, okay, look at that, approaches 2. When x approaches 1 from the right, the value of your function also approaches 2. And so the one-sided limits are equal. Conclusion, the limit of g of x as x approaches 1 exists, and it is equal to 2. In which function does the limit exist as x approaches 1? And if it does exist, what is the limit? So this one is defined by f of x is equal to x squared. The other one is a linear function defined by this. G of x is equal to x minus 1. So let us investigate. What are the limits of this function when x approaches a? For our quadratic function, as x approaches 1 from the left, the value of your function approaches 1. Look at that. It's 1. As x approaches 1 from the right, the value of your function also approaches the same point or the same value. It's also 1. Conclusion, the limit exists for x squared as x approaches 1. How about for our linear function? As x approaches 1 from the left, the value of our function is 0, or the value of your function approaches 0. And when x approaches 1 from the right, the value of your function also approaches 0. So conclusion, the limit exists for this function, and it is equal to 0. This is a function defined by -1 over x minus 1 squared. So this is a rational function. This one is another piecewise function. And it is defined by this. It is equal to 2 when x is greater than 1. And it is equal to -x squared plus 2x when x is less than 1. Okay? So in which function does the limit exist when x approaches 1? Here, in our rational function, as x approaches 1 from the left, your function approaches -infinity. When x approaches 1 from the right, your function approaches -infinity. So your function or your one-sided limits point towards the same direction. But -infinity is not a real number. And so our conclusion here is the limit of this function does not exist as x approaches 1. How about this one? When x approaches 1 from the left, your function approaches 2. Okay, it approaches 2. When x approaches 1 from the right, the value of your function also approaches 2. Conclusion, since their one-sided limits are equal, they are equal to a real number 2, the limit of this function g of x exists as x approaches 1 and it is equal to 2.